I will speak now about problem outside, and it's hazards for the installation site, for tunnel portals and management of natural hazard related to tunnel construction. So you have natural hazard underground is exactly a problem from geomechanics. I let Robert speak about. He's a very, very good rock mechanics engineer. Another problem we have to manage, as I said before, is hydrogeology, water inflow leading to flooding in tunnel. Another point you don't have to forget is a dangerous substance you can find in tunnel, like gases, asbestos, radioactivity. I was personally confronted with asbestos and radioactivity. It's not very easy to manage. And then you have the risk on the surface. That's in mountainous region. You have the risk for access roads, for rocking sites, for tunnel portals. One of the risks in Europe, since it's more accurate in Europe than here in South America, is avalanche. But I think when you are working in the south of Argentina, you will have the problem too. You have problem from rock falls, water and mud flooding. I was in the region of Salta for the weekend, and I saw a lot of problems of mud flooding and torrential lava. Here in America, you are confronted with earthquake. In Europe, it's not everywhere. We have problem for earthquakes. There is problem for earthquake in the Alps. There is big problem in Italy, and at the border of Europe in Turkey, in Greece, there is a lot of problem of earthquake. Okay, that's the scope of my presentation. I will list, of my opinion, the hazards and speak about prevention. I will present some problems, some example of portal implantation. That's all my personal experience. That's the measure we take to manage these hazards. Prior to construction, that's very important, and during construction. And I will give you a special example we developed for the Jornadas project of an avalanche management organization. And if I have time, I will show some films of avalanche blasting. Then perhaps at the end of the presentation, that I will speak about, give some advice for management in deep tunnel. Some example Robert Scaler showed to us. I have to manage it in the tunnel. As there is one point, is a scientific point of view. You need really to understand the problem, but you have to manage it in an easy way, in a simple way in tunnel. Okay, you know what this is? That's avalanches, and that's a working site. And the safe zone for working is only here. It's a very heavy, hard winter in Europe these years, and my colleagues say one day before, define the safe place. And one day after, the guides mine the avalanche, and that's the result. But I have to say, it's an extreme case, but it is possible to manage such situation. And it is possible to manage most of the risk we can have outside a tunnel, and the natural danger, the natural hazard, it's possible to manage that, but you have to have, I have to experience people to do that. And my goal today is that you don't forget the risk and organize you to manage this risk. Hello. What you can have in mountainous region, as I say, snow and avalanche, very often, rock falls, landslide, water flooding. It can be natural or artificial. Mud flooding, and if you have every precipitation, a lot of water in the soil, you can have torrential lava. I see a lot of examples in the Quebrada de Huamamarca. You can have glacier falls. You can have earthquakes. The problem of earthquakes is clear. It's not evident to manage, and they can influence all of the other hazards. Then in mountains, you can have extreme storms and extreme winds and negative temperatures. Did I forget something? perhaps? I hope no. Alors, for me, the first prevention measure is to choose an appropriate place for your working site and tunnel portal. Huh? The goal is exactly to avoid natural hazards. Huh? You have also to avoid the problem with water like springs, swamps, and if you are close to cities or village, it's better to avoid to build in constricted areas. And what you have to search for is good rock with favorable structural orientation and enough space for installation. You have to find good working site. The problem is the mountains. It's difficult to find good working sites. I give you an example. I show in the first presentation these pictures. That's a working site. That's the intermediate adits of Verden at the Lötschberg. I said in my first presentation, it was the only place in the south part of the Lötschberg base tunnel to construct, to begin a tunnel and to initiate an access gallery. But there is a lot of problem with this place. You have avalanches here, you have rock falls here, and you can have big water inflow, and so we had to protect this place in advance, and the protection of this place takes 1.5 years to protect this place. After we use this place during, I think, 8 years, but it takes time to prepare this place. And for example, all the installation is these are calculated against the avalanche wind and the blowings through avalanche. As I said, if possible, enter in a good rock in a steep slope. That's the ideal situation, but I have to say it's normally very often not possible. The problem if you are designing high-speed and railway tunnel, high-speed railway tunnel and high road tunnels, you cannot enter straight on. You will probably enter in a curve. So you have to manage that, especially in road tunnel. If you have a long tunnel straight on, and you go straight on with your portal, the people, what they will be driving, they will be dazzling by the light. So it's better to enter in a curve for a road tunnel. Alors, if you are not in a good situation with a steep slope, you have to take stabilization measure. And normally, if you're in an entrance in a curve, in an oblique entrance, you will have long retaining walls. And very often in the mountain, you cannot enter directly on the rock. You will have loose rock, so you have to take solution to dig your tunnel in loose rock. Here's an example, the main portal of non-rounds. So here we have to drive 20 meters of tunnel in loose rock with pipe and radars before to reach the good rocks. And we have to stabilize the portal zone with pre-stressed anchors. That's a very standard enter for a tunnel. And here we have the problem. We have the railway line, where the railway is going with 40 kilometers per hour. It's in thin zone, and you have to enter. That's a mountain railway. We have to stabilize the face, the portal, to avoid any problem with the train. And it is a very common solution to stabilize that with pre-stressed anchors. I show this picture another time at the beginning of the project. Here, the problem we have. First problem is the lack of place. And the other problem you have here cliffs. So we have to manage the risk of falling rocks, and we have to purge the cliff before to begin the portal. We have to reinforce the portal, And we use a muck here to get place. And as I show you these pictures before, there is problem from negative temperature in winters. Another example, and the other side of the tunnel, here's the problem, there is no place at all. Here you have an international road between France and Switzerland. There is the river, and there is no place. And here you have a beautiful unstable blocks, or potentially unstable blocks on site. And I have to say, it was the best place to drive our tunnel, to construct our tunnel, but there is a lack of place here. And what we do, first, we solve the problem of the unstable blocks, and we anchor the blocks before. And here, for the access, we decide, this is a short tunnel, we access from the other side, so we mine the portal from inside the tunnel, and we search solution to don't put too much rock on the street, on the road. The bridge was under construction, so we blasted the portal, we blasted the portal not in one shot, but we do it in some steps to avoid to have too much rocks on the road. And we have to stop the traffic before mining and opening directly after. Another example, that's the Lötschberg. That's a railway train with 200 kilometers per hour. The speed of the train is 200 kilometers per hour. So you have a big curve at the entrance of the tunnel, and there is no place here. And you have the river. In between, there is an existing railway line, so it's not so easy to begin such a portal. And what we do, we were very imaginative. That's the other side. We use a lot of different solutions of stabilization systems. Sometimes only rock blocks. For example, here that we have anchor walls with sprayed concrete and anchor. And here we built big walls. Here, some of them were how to say that. Were fixed on piles, but there is we create here a big walls to install our portal. So we create a big place here to begin our tunnel, and the goal was to install the TBM. So you have to be, if you are confronted with such solution, you have to be imaginative, to search best solution to find the optimal way to create your working site. And here we have no space, so the camp for the people and the main working areas was on the other side and the river, and the muck was transferred with bank conveyors. And I show this example before. Here, that's the time we need to construct the installation site. Sometimes that's 6 to 8 months, and in extreme fall, it can take more than 1 year. So, if you are planning such big tunnel, don't forget this phase. You have to have time to construct your installation place. You have to allot enough time in your project schedule, and it should be studied in details before. Don't let the contractor arrive and install you. He needs to install, but it should be planned in advance, and time will have to be allowed in the schedule in advance. And know how to manage these natural hazards. So you have to do that prior to construction. So the first thing is to go with experienced geologists on site. Experience is very important. And one of the things is to research the specific geological data. It's to research the historical data on natural hazard. And very important, that's very important, is to speak with local peoples and to understand the local name of the place. It will give you a lot of details on the hazards. And only after you have to begin with your ground investigation. And one of the key points for the tunnel is the assessment of the hydrology. And if you have problem, for example, with avalanche, with glacier, you have to consult, or if you have to consult special expert for that. Okay. Let's go now in details. Avalanche. Alors, the best solution is avoid to try in winter on exposed site. And you have to adapt your project and schedule for that. So you have to choose the best working time without risk. And if it is not possible, it is possible to map, to study the avalanche. There is, in the European countries, there is special institutes that are managing the avalanche, that are studying the avalanche. So you can map the avalanche in advance and search for historical data on the avalanche. The occurrence is very important. And you have to consult exactly these people to make an assessment of the avalanche risk. And you have to manage your avalanche. And so you have to blast the avalanche. So you have to study where it is possible to blast the avalanche, where are the best points. It is possible sometimes, it's depending on the type of avalanche, to deviate the avalanche. To stop it's difficult, but to deviate it's possible. And if you have to work in such region with a risk, it's possible to calculate the snow pressure on the affected sector, and you have to build very, very heavy buildings to resist to the snow pressure. And another point you should not forget: if you have to open road, you have to know where are the roads in winter. So you have to make a survey, where the best is with GPS. You have to know exactly of the centimeter where are your roads. I will show you some example after. That's an example of avalanche mapping in Switzerland. That's Jornadas working site. Here, the working site is here. We have risk of avalanche here, on 2 places on the site. And here, we have our camp. Our camp is here. We cannot use this place. It was possible to use it, but there is a big risk of avalanche. So we let work before the project, specialized engineer to calculate the avalanche risk. For the rock falls, you have to do approximately the same things. You have to, first of all, you have to go on site, go with a specialized geologist to control the risk of it's the cliff. If there are morenic material too, you have to go on site and control that. So it's possible to perform rockfall simulation. And so you have to map, you have to make a mapping of the affected sector. And each spring, you have to go on site, control the situation of the unstable blocks on the cliff, to control if there is a movement of the blocks due to the winter, to the frozen of water in the cracks. It is possible to anchor the big blocks, and it is also possible to blast the unstable rocks. And what you can do is install grids to retain the block, or to install grid to stop the flying blocks. That's a different option. And every year, if you have such blocks, you have to go on site and evacuate off the losing material. And it's also possible to build protection dams. An example of mapping of blocks, it's on a forest over a portal. the geologists go on site and go through the forest and map all unstable blocks. And we know exactly where it is. You have the coordinate of the blocks and exactly the altitude and the volume of the block. And there is an assessment is that the tip of risk, the tip of hazards, and you have the block can slide down. And so we do that for all the blocks. At one moment, there is someone who has to decide what we will do with this block. And if it is decided to let the block on site, it's important to control every year what is going with this block. And sometimes we let the block, and after 2-3 years, we decide to mine it or to let it go down, to help it to go down. Here is a good example of blasting and big unstable blocks. The block is 200 meters over a portal zone. And the decision of the geologist was to blast the block. So the people are specialists in such operation, and they are here preparing the block for blasting. And here, exactly the same people are in the same region are anchoring the cliffs. But you should have people to do that. In Switzerland, we have people, some companies who are very specialized on that, and then they work in Switzerland, but sometimes in Europe, in Iceland, in Greenland, to do such job. Here you have the boring equipment, and all the system is suspended. Here you can see exactly the boring equipment used to be used on cliffs. Well, most of these people are mountain guides, I have to say. And that's always the same place. After that, you have the loose material. And one of the options you can have is to evacuate the loose material. You can drive the tunnel with a pipe umbrella, for example, but it takes a lot of time. Or to evacuate the material. It is one of the solutions. You have to have machine to do that. But it's possible. It's one of the solutions is to evacuate the materials. And that's the situation. The material have been evacuated. And here, the people are installing grid, metallic grid over the portal to avoid that small blocks fall on the working areas. Another very important problem is the water flooding, the mud flooding. We call also it torrential lava. So if you are at risk of flooding, one of the solutions is to make a flooding simulation and to calculate the risk of flooding and to map, prior to arrival of the contractor, the dangerous sectors. And so you have to make two things, or to decide we don't work in this place, or we build protection dam. I think for you in Argentina, in the Andes, that's very common. And you have exactly the same problem of mud flooding. I saw in the weekend a lot of such examples. So you have to map before the risk of torrential lava. You have to consult historical data. If you have satellite pictures, that's very interesting to show the satellite of the aerial pictures before, and to decide what we will do. And if for that you can perform protection deviation dams, and very often you can reinforce ford. I saw a lot of them this weekend. That's an example of a dam against water flooding constructed. The risk here is that we have a big rain, and the risk that the water is a lake, and it's a reservoir lake, and that the water it's a water intake, that the water comes and floods the complete tunnel system. So we had to protect the water intake, the upper water intakes of the project with a dam. So it's very simple to construct the standard construction methods. Other problem we had are typical. That's the torrential lava. Here you can see that's the tunnel portal, and we have to work on that place only 6 months. And 2 months after the beginning, we have a torrential lava with a return time of 20 years. And that's the risk we had. And we place the portal at a very strategic point. It was not affected by the torrential lava. It's only the way to the installation place which is affected by that. And we have some risk for the installation place, but we have when the torrential lava occur, we don't have any work on earth or death. The people stay on the portal zone where they know it is safe. And you know that very good in Argentina. You build simply such ford to avoid some problem, to manage some problem. And after the mid flooding, you have to come back and evacuate the material. For the landslide, the best thing is to avoid to construct portal in the landslide. So you will have a lot of problem with your tunnels, and tunneling in landslide is not very easy. It's dangerous, and you have after some years you will have a lot of problem with cracks in your tunnel. And avoid to construct tunnel in landslide. We have one big problem in the region where I live. So there is a tunnel in the landslide, and the tunnel construction was stopped for 5 years due to this problem. And there is a lot of experts that one of the best solution is avoid to construct tunnel on landslide. But if your installation site or your roads could be affected by landslide, the best thing is to install a geodesic survey. You can also use satellite survey, satellite old aerial pictures, and you have to perform ground investigation. And one of the solutions to stabilize landslide is to drain them. But it's not always easy, and you know that there is always a risk by reactivation or activation of landslide by earthquakes. Another point is you can have problem with glacier. There was a big accident in Switzerland for 50 years with more than 70 people killed. That's a landmark disaster. So you have to be prudent where you are working under a glacier. And also, you have to survey the movement of the glacier, and you have to have an assessment by specialists. And you have the same problem with landslide, with glacier fall. It's to follow the speed, the advancement speed of the landslide of the glacier. And if you look for, you see an acceleration, the risk is bigger. The problem, very often the problem is to know when will the accident occur, and it's very difficult to predict that. So it's better to avoid to work in such situation. I think another thing is always the storms, the winds, the earthquake, negative situation, negative temperature, snow. In the contract document, the contractor should be informed of this hazard. As client, you have to say to your contractor, it's your risk, but you have to be ready for that. Perhaps for the wind, you can come before, some years before, install some wind measurement. But for me, it's a risk of the contractor, but you should be prudent as client said, okay, contractor, you have this risk. And the contractor should take measures to reinforce the installation and buildings. And as I said, you know that better than me, huh? You have the risk of activation from earthquake. Huh? Okay, now, some problem of snow. I saw this picture before. Huh? Negative temperature. You can really have big problems with frozen water. Huh? That's very dangerous. Huh? That's sliding. And it's destroyed the pipe. It could destroy a lot of installation. I think as client, it's exactly the same for the contractor. What you have to do to manage all the natural hazards, it's to, during the construction, is to define specialists, people who are in charge of controlling, surveying the natural hazard, and it is better when you define clearly the job specification of these people. And if necessary, you have to organize an external support assessment because perhaps you don't have the specialist on site, but your people could telephone and exchange with specialists if necessary. And very important, it's to define clearly who is in charge of the problem and who decide and what is the alarm chain. And these people, these specialists, has to, with external experts, has to define the control interval between each control, for each natural hazard, we have to control you have to define what is the control interval. And it depends on the situation, and if you see acceleration, you have to make more control and more survey. And very important is to organize an efficient reporting on that, that you can also always control the past data. You have to define safety regulation. If there is risk for the people, you have to define what they have to do if the risk is bigger. And you have to define alarm and evacuation process. And the people on site, there is a need of evacuation. The people have to be trained, and the management of the site have to be trained for evacuation. I will show you an example I have organized as client. That's a really special avalanche situation. So we had, at the Jornadas project, we work on high mountains. We are at the ridge of the Alps. It's not so high, it's 2,000 meters, but there is a lot of snow in winter. So the first things we do, we search to have experienced local mountain guides to help us to manage the situation, and we discuss with them about the risk for the people. And these people, this guide, take a support by avalanche specialists. And in Switzerland, we have a very efficient institute on avalanche. So the guides work for these people with information, and this institute gives advice to the guides. And what we define with the guide is a special safety regulation for working in winter time. It's clear. The priority is the safety of the worker. And we decide that there is only one man who can decide, is the mountain guide on site, and these guys decide if we can work or not. And nobody on site has the right to contest the decision of the mountain guide. It's really the decision of the mountain guides. The problem, they have very often to decide to stop the work, and if there is a management of the client, of the contractor, they will say, you should work a little bit more. But we are speaking from safety of people. We cannot replace the life of people. So one has to decide, and it is the mountain guides. Very important, it's to define the flow of information. how the information goes from the mountain guides to the people. And here, in fact, for example, the first decision of the guide, it's at 4 o'clock in the morning. So he had to say, he looked what is going on this night. Did we have snow or not? And after he decide if we work or not. And you have to transfer this information to the people of the contractor. So it's very important to define the flow of information. And there is a standard rules in a lot of countries. If no evacuation is possible on a working side, you stop the job. That's very common. Okay. Here you can see the mountain guide is coming on site with skis in winter. That's the workshop of the contractor. And what they are doing is there is a system to control the stability of the snow. Here there is the mountain guide as doing tests to control the stability of the snow. They have special reporting for that. They look how the unstable layer in the snow, and there is a reporting system. And they look really the snow crystals, how they looks, to understand what is how is the situation, and they calculate the break pressure of each layer. So they are doing it's a steep slope. They are doing there is some risk to do that, but they are doing that very often on site. And they look also during winter what is going on with natural avalanches. So they go outside with skis and look for the natural avalanches prior to the working period. And they control what is going on. And they are doing such photos or such reporting for us. And here you can see the first page of the safety regulation. What is the goals of this regulation? What are the reference documents, and who is responsible for? And you have a simple evacuation scheme, but it has to be prepared in advance. And it's only the mountain guides who decide who is responsible for that. And what we do on site, we blast the avalanches after each snowfall in winter. And the working time is decided according to avalanche risk. There is a big influence on the snow quantity and quality. And the problem is often at the end of the winter with high temperature. In such case, we can only work in the morning. We begin very early in the morning, and we stop at 11 o'clock at midday, because there is too much risk in the afternoons. And all people on site are equipped with special equipment. There is avalanche victim detectors. They have sounding bars. There are the snow shovel. The goal is that if there is an avalanche, they can find the colleagues and be found if there is in the snow. And clear, we have to make training. So we instruct the people, we exercise the people, and we have a communication system. We have two redundant systems. So we have mobile phones and radios. And we had also to manage the road. So there is a gatekeeper on the road to open or close the road according to the avalanche risk. And one problem we have, there is a lot of problem going up with skis. So we call that ski tourer. And we have to manage that. So we have to inform people about the risk. And if we blast avalanche and if there is people, we will be responsible for that. Some picture of avalanche blasting. Here you have two dams. One of the dams, the other. At the working site we had is exactly here. And here you can see the effect of power snow avalanches. That's very, very dangerous. That's, sometimes it's go down with more than 300 kilometers per hour. Huh? And what we do, we come on site with helicopter and blast the snow. So the guy decide where they will blast, and after that they control if there is an avalanche or not, and do the reporting. It can be done in a very simple way, but it's important to have reporting. If there is an accident after, if you have to go to the court to explain what we have done, it's very, very important. And that's instruction for the worker. Very simple, how to find the colleague, how to give the alarm, what they have to do in case of evacuation. If you are working, I think you can have such problem in Chile, in the south of Argentina. If you had to open the road, it takes time. We have to open 11 kilometers of roads. It takes a lot of time to open the road. One of the problems is to know where is the road. So we made the survey, and to open the road, we have a team of 7 people. 2 mountain guides, 2 geometers, so to know where is the road, and 3 people, specialized people, to take the snow away. But it takes time, and you can see here's a machine to blow up the snow. And it's not done in one shot. We have to come here, make a first layer, a second layer, a third layer, and it takes time. And the problem when we begin to take the snow away, you have to know where is the snow. So the geometers, the surveyors comes and mark the road with spray on the snow. And one of the problems we have, if you have to keep road open, you can have avalanche afterwards. You have to blast avalanche afterwards and come back every time to reopen the road. And it's a hard task, and it costs a lot of money. And you have to need explosives. The problem is if you are very late in winter. Exactly the problem. It's difficult when there is no power snow. There is the old snow to blast, and for power snow we blast the snow in the morning directly after the snowfall, and for very heavy snow, old snow, we do that at the end of the afternoon, and it's difficult to blast such snow. And you can see here that's a typical power snow avalanche. As I have a good reaction to blasting, and wet avalanches do high temperature. It's difficult to initiate. The speed is very big. That's its come. It is not so speedy, but it's got down. But it's very dangerous when it comes down. And the problem with such avalanches, the hazard is always present. That's a problem with such thing. It's exactly the same with rockfall, with landslide. You keep in mind that natural hazards are always present, and the people, the site management, have to know that, because you can always have hazards. No, I have the problem with my. No? It's time to. Let me 5 minutes. No, I will say something about management of hazard in deep tunnels. That's the pragmatic point of view of me. It's take me 5 minutes. You should know that prevention is always better than reaction, and so you have to define the hazard scenario in advance, and you organize a health and safety plan. I will speak about this afternoon, and you have to have a risk assessment, ongoing risk assessment, and you have to identify and understand the physical mechanisms in advance. There is a good presentation before. Always the first priority you had is the safety of the worker. And I have to say, some phenomena in deep tunneling are uncommon. I have to say, and one of the problems we had, for I saw that in the International Tunneling Association in the group on deep tunneling. Not all the people we are speaking from something, but not all the people understand the same things. So you have to understand each other between the client, the contractor, the engineer, and it's very important to clearly define the terminology. If I had an example, is that squeezing or buckling? That's a very interesting example for me of squeezing. That's a buckling phenomenon, but not all the people are understanding each other. That's the problem we had in international group with specialists. So you have to understand with your colleagues on site. And it's a very easy system is to do that, is to describe the hazard scenarios with simple sketch. With simple scheme, make it explain to your colleagues what we can do. Very, very simple, but be sure to understand each other. And if you have problem like rock bursting, spalling, so that's also very important to describe the intensity. And I discussed with our French colleagues with constructing an access to a mine in Chile, and they use a system, and they say, okay, the risk is green, yellow, red. And after what was red at the beginning, after two weeks, it was green. So it's not a good system, but you have to find description. What the people are hearing, what the people are seeing, what is the deep of the phenomenon up there to find solution, to describe the system, because when such phenomenon occurs, there is normally no one of the site management. Water inflow, that's very important in deep tunnel project. If you expect sudden and large water inflow, you have to probe systematic add your tunnel. You have to make probe drilling. If there is a big pressure, high pressure, you have to use blowout preventer to do that. And in descending access gallery, you have to have enough power supply, enough pump. Here, in this picture, we have 32 bars before height of our tunnel or machine. Okay, and don't forget dangerous substance like asbestos, gases, methane, H2S, and the risk of contamination for natural water. If you have some substance in water, the people should avoid to drink water in tunnel. Manage the temperature of the rock, of the water. Don't forget that in the preliminary design. And don't forget also that tunnel can influence things outside. The primary risk is the lowering of the water table. You can lose existing springs. You can induce settlement on dams. That's very dangerous on Archdam, on pipelines, for example. And you have to avoid contamination of soil and water. Okay, I come to the final remarks. Also, take time to read the publication of the ITA. There is a lot of advice in it. And if you are really in a very bad, difficult situation, you have to find solution between the client engineer and the contractor to manage the situation. You have to go out of your contract. You have to make special task forces, small group of people, experienced people to manage the situation. And for that, you have to take collective decision and special payment regulation. And you have to prepare that in your contract before. But sometimes it's the best solution to solve very difficult problems. Thank you very much for attention.